Going. So thanks very much. If our speakers would come on camera, I'd like to introduce them. First, we will have Gavin Kennedy. Gavin heads DWave's global head, is the global head of professional services at DWave, a role he has been in for the past 3 years. He has over 25 years of experience successfully executing and leading teams within services and IT departments of 5 very diverse companies in 5 different markets and industries. So a lot of experience across many kinds of businesses. Pegre Pierre-Louis, who we were typically call Pierre, has a PhD in systems and industrial engineering and over 20 years of experience in analytics and optimization space, spanning multiple industry verticals. He has spent a decade in the power systems industry, building energy management systems, energy grid optimization applications, and other analytic solutions to support key public services and infrastructure across the United States and Europe. Currently at DWave, he leads a team of solution architects. They work closely with DWave's customers and support them in their journey to achieve business value through quantum computing and optimization. Our third speaker is Dr. Maya Iodel, is the lead solutions architect at DWave, and she works with global enterprises to solve complex optimization challenges using quantum, hybrid, and classical technologies. She holds a PhD in operations research and has over a decade of experience in applied optimization. Her work at DWave spans areas such as scheduling, logistics, supply chains, finance, resource allocation, and energy systems, helping organizations turn their toughest challenges into practical, high-impact solutions. So with that, I'd like to have our speakers take over from here.
All right. Thank you, Susan. As Susan mentioned, my name is Gavin Kennedy, and we're going to start today with a little bit of an overview of DWave, just to make sure everybody on the call is familiar with the company and what we do as a whole. So to start, I'll ask you to kind of look at the graphic in the top right-hand corner, just to explain that DWave does have a full service, full stack offering of technology as well as services. You can see there from the Advantage 2 computer, which is the world's largest quantum computer, where we use quantum annealing technology and offer over 4,400 qubits as part of that computer and that offering. We also have our Leap platform, which allows clients to access our hybrid solvers through a production grade cloud service. And then also we have the Ocean Toolkit, which is a platform that allows for open source access for our customers to open source Python tools to assist with development, and is easily configurable to allow you to be able to access those solvers in the quantum computer itself. And finally, our launch process, which is our professional services engagement model, where when you do engage with professional services, you get access to our skilled resources who will be able to help you take your problems and your use cases and build applications all the way into our production environment. In the middle, you will see a list of some of the customers that we currently work with. And then also on the bottom, you'll be able to see kind of the breadth of knowledge that DWave and experience that DWave brings to the market. You can see there the number of patents that we hold, the number of papers that we have had published, as well as the percentage of our resources and employees that have and hold PhDs. So then over to the left, again, some of the highlights that are called out. I mentioned some of these already, but you can see that we also have had one of those scientific papers that I mentioned. We have had our quantum supremacy paper published in Science. And the other one that I will highlight is from a professional services perspective. You can see that we have held or successfully executed over 20 plus successful engagements over the last 18 months. And then you can also see in the second grouping there that we have had experience with over 30 plus different use cases for different markets and different industries. And we'll go into a little bit more detail later, some of the engagements from a professional services project, as well as some examples of those use cases. And as always, want to point your eye to the bottom left. I'll give you a couple seconds to read the quote from one of our customers at Ford Otosan, who is one of our applications and customers in production today. And with that, I will hand off to Pierre to go into a little bit more detail about the hybrid solvers.
Thank you, Gavin. Next slide, please. Yep. So this is an example of a life cycle of a problem in building a solution on our system. So you would start with the business problem, and this can be a plain language description or definition of what the business problem is. As an example, this could be, say, for instance, your business problem might be figuring out a schedule for your employees in a particular plant, as an example. And then once you have a clear description of what the business problem is, then you can flesh that out into technical specifications. And this can be specific. This can be the process of transforming specific business requirements into technical requirements. Then using those technical specifications and requirements, you can now move on to formulating a mathematical problem. This is the mathematical formulation. And really what the mathematical formulation is this is just a set of equations and constraints and objectives, just mathematical equations that represent the elements that are part of the technical specification step from earlier. Now, having this mathematical formulation in hand, coupled with relevant data for the business problem, now you can construct a model. This is where you pass to the model construction stage, where you combine the mathematical equations with your data to actually instantiate a model that's ultimately going to be solved by calling our hybrid solver, which is the last step. Next slide, please. Lately, we've made a series of advancements in our hybrid quantum computing, and in particular, when it comes to our nonlinear program solver, which now supports a growing set of use cases. And in talking about hybrid solvers, and our hybrid solvers, they combine the best of quantum and classical resources to solve really complex problems. So our latest and greatest, the nonlinear program solver, excels really well at problems that contains nonlinear relationships between variables. Still, obviously, this is a much larger set of use cases than, say, a quadratic solver, which would start at the quadratic level in terms of interactions between variables. So now we can actually support relationships that go beyond quadratic, just general nonlinear. And with that, this really enables rapid application development. So given a particular business problem, because now you can represent more complex relationships between variables, that allows you to actually develop applications more rapidly on the one hand, but also on the other hand, that supports the ability to create solutions for a larger set of application problems. And in addition to that, our nonlinear program solver also adapts our new quantum processors, and you have high availability for enterprise applications, which you may have noticed on the previous slide that Gavin shared. We have greater than 99% uptime with our Leap services. Next slide, please. All right, so why hybrid quantum computing now? Given that you have a very complex business problem, a problem that's computationally complex, why would it make sense to use quantum computing now to solve that problem? Well, to justify this, we're going to look at three key reasons why classical comes up short for such problems. One is the problem might be too complex for classical solvers or for classical computing in particular. So when you have a problem with so much complexity, a lot of times we can do really, really well on those problems because of quantum computing. And another reason as well is, even if you're able to solve these problems using classical computing, sometimes it just takes too much time. And in particular for business problems, time is essential. It may not just be enough to solve the problem, but you need to be able to, you need to be able to solve it fast enough in a way so that it can have business value. Because if you need the response in 5 seconds or in 30 seconds, it doesn't help that you have classical solvers that's going to take 10 hours or days to solve that problem. So this is another gap where quantum computing can make a difference in being able to solve these problems a lot faster than you can using classical resources. And finally, another element, another reason why quantum makes a difference over classical is that even if you're able to solve the problem with classical resources, and maybe you're able to solve it in a reasonable amount of time, a lot of times what we also find, because of the complexity of the problem, this can consume a lot more energy than you would, say, using quantum computing. And this really, in a nutshell, represent the concept of quantum realized, which is you're able to get good solutions to complex problems either you weren't able to solve before or much faster and with less energy than you're able to do using classical resources. Next, please. So the nonlinear program solver that we have now encompasses 4 schools of optimization in one solver. Many commercial solvers nowadays will fall under 1 or at most 2 of these schools of optimization, whereas we encompass all 4 of them. And what are those 4? We're talking about quantum optimization, obviously, because our solver takes advantage of our QPU, which really ultimately represent quantum mechanical effects that allow us, we take advantage of quantum mechanical effects to solve optimization problems. And in particular, this refers to natively non-convex problems. And then there is combinatorial optimization, the concepts of list sets that we find very commonly in combinatorial optimization problems that are highly constrained. Our nonlinear program solver includes and incorporates these concepts natively. And currently, as I mentioned before, very few commercial solvers available today support these constructs. And there is the school of mixed integer or linear programming, which is a lot more common to most people. And this is well suited for linear and convex optimization problems. You get polynomial time performance for continuous problems. We also encompass this school of optimization as well. So that's also included in our nonlinear program solver. And finally, tensor programming. And tensor programming, that's referring to high-dimensional array operations. Many applications nowadays, particularly in data science and machine learning, make use of tensor programming, and we also incorporate that as a natural way to represent a suitable problem as part of our nonlinear program solver. Next, please. All right, so what does a quantum application look like? On this slide here, just wanted to give you an idea of, at least at the high level, of the processes or the architecture involved in building a quantum application. So on the left side, in the left box, you have the customer infrastructure. So from the customer infrastructure, starting with a customer application, using customer data as problem input data, and using our Ocean tools to build a quantum optimization model, combining the model and the data. Now we have an instantiated problem that can be sent to our Leap Quantum Cloud Services. So looking at the top arrow in the middle here, you have an encoded problem that is sent over to our Leap Quantum Cloud Services. So what's happening with our Leap Quantum Cloud Services? Well, in terms of infrastructure, so you can see you have our hybrid solvers and various classical resources, such as CPUs and GPUs on AWS. And using our secret sauce, we'll figure out what portion of that problem that comes over that can be sent to the QPU. So this is represented here as a QPU subproblem. So we'll also use our quantum computers on DWave infrastructure. So with the combination of quantum and classical and our hybrid solvers, we solve that problem, and then now we send the encoded solution back to the customer infrastructure, and that is now what is received at the bottom of the customer infrastructure box, which is the optimization solution output. So you can see here, this is a very clean setup, and as far as customer data and application, all of that the customer controls, all of that is managed by the customer infrastructure. The only thing we receive is the encoded problem, and then we send back the encoded solution. All right, and with that, I'm going to pass it over to Mayora, who's going to talk to you a little bit about the different keys to success in building quantum applications. Mayora?
Thanks, Pierre. So two categories of factors that we have identified and would like to talk about today are, one, the use case selection and the data available to support that use case. On the other hand, we have the customer engagement and capability building. And by capability building, I'm talking about the ability of a customer to feel empowered enough to be able to use our solvers, define their own models. And we have identified that these factors actually help to have a successful project. Can I go to the next slide, please? So before we dig deeper into those factors, we like to talk about the definition of success. For different clients, we have different KPIs. For some clients, the ability to be able to model very complex constraints really help. The fact that they don't have to do additional pre-processing or post-processing in order to be able to capture some complex rules is enough to be able to define that as a successful project. There are also the more obvious ones, which is faster time to answer. So say a client is solving their problem and it's taking 6 hours, now they can solve in 5 minutes. That's a big impact to that business. Another factor is quality to answer. So quality could be things like the cost of doing business. If we are able to reduce that cost, that makes the business more profitable, and that is considered success. So we have a range of these different factors depending on the client we are talking to. So overall, when I'm talking today, I'll be talking about within the context of this definition of success. Next slide, please. Okay, so we'll start by talking about the use case selection and data availability. Next slide, please. Optimization is one of the core areas that we focus on. Annealing technology is particularly designed for these kind of problems. And we see optimization problems in many areas of life. The three main things when it comes to defining these problems are, do we have some choices we like to make? And are the choices constrained by some rules? And finally, do we have a quantity we'd like to optimize? So we have this quantity, we want to make it as high as possible, or we want to make it as small as possible. And I'll give an example in the next slide, where we are then talking about can I have the next slide, please? If we look at the production scheduling problem, for example, the variables, the decisions we are trying to make could be related to the start and finish times of tasks. We might also be interested in making decisions around the assignment of resources to tasks. So resources like machines, we might want to assign one of a set of suitable machines to a particular task. It might be human resources where we want to assign a particular staff to a task. And usually we have a range of constraints. In the case of human resources, we might need to ensure that they have the right skill to perform that task. We might also need to ensure that they are available at that particular time. In the case of assigning machines to tasks, it might be that certain machines cannot perform certain tasks, so we want to ensure that we match the right task to the right machine. It's also common that we have constraints around deadlines where we want to ensure that we meet a customer deadline. And more often than not, we have one or more objectives. For instance, in this use case, we would have, we want to minimize the overall duration of producing a set of things. Say cars can be examples where we have 1,000 cars and we want to produce them as quickly as possible. There are also common objective we often see in this area is things like setup costs or cleaning costs. Depending on which task comes before or after another one, it might increase or decrease the cost of setting up or cleaning. Next slide, please. So to reiterate, even within the context of solving optimization problems, for most of our customers, we've seen more value where the optimization problems are very complex. That is, they've struggled in the past to use other traditional optimization tools to capture the complexity of the problem. So the more complex the problem is, the better it is for a nonlinear solver. So we're able to model linear, quadratic, and higher order interactions. And because we're able to do this so natively, we tend to outperform most of the solvers in this area. We're also able to handle larger problems with our nonlinear solver. With a hybrid architecture, we're able to take advantage of our classical processes and our quantum processes, combining them together in an intelligent way to be able to handle problems with a lot of variables. And this also is one of the reasons why our customers are very pleased to work with us. And the last one, while our technology is able to handle both discrete and continuous variables, when our technology is better suited for discrete decisions, by the nature of the technology, the quantum process being natively discrete, in terms of like our qubits and Ising model, we perform a lot better on discrete decisions than continuous decisions. Next slide, please. I'll give 2 examples of our clients in production today. We have Patterson Food Group and Ford Otosan. Patterson Food Group use case is a workforce scheduling one, and the way they measured success is in terms of time savings, and we were able to save them 80% of their time, which they were very pleased with. On the other side is Ford Otosan, where they are trying to produce vehicles as quickly as possible. And the existing solution they had could create a solution for 1,000 vehicles in about 30 minutes. In our solution, not only were we able to handle more constraints, we were also able to reduce that time to only about 5 minutes. Next slide, please. So another area, although we more focused on optimization, we also have significant research and customer projects related to AI and ML. One of the interesting ones is being able to sample restricted Boltzmann machine. And we also have examples, at least within the context of our quantum advantage work, where we show that which I'll talk about in the next slide, is our material simulation work. Next slide, please. Okay, so we've showed through extensive research that we are able to do material simulation in a much shorter time than the time that would be required on some of the fastest classical computers. This is one of the most impressive work that we've published, where we were able to show that things that would take a very, very long time, over 500,000 years, could be done in only minutes. We have also been able to work with customers on areas such as drug discovery, where we're using the QPU to sample high quality solutions within a bigger framework. Yeah, and I'll move to the next slide, please. So this is, I'm sure this one does not come as a surprise because data is always a very important part. When we have good data from day one, we tend to see a lot better performance because we want to ensure from day one, as much as possible, that the data is realistic. The data correctly models what is happening in reality. For some customers, we're able to work with real data. For other customers, there's a level of anonymization that has to be done. But regardless, we want to ensure that the data is representative of a real life scenario. It also helps when the data is accurate. So say we are looking at durations of tasks, we want to ensure that those durations are actually correct. And also when we talk about data that is current and relevant, sometimes when data was captured too long ago, it might no longer be current and relevant. And last but not least, accessibility. We want, once we have the data in a format that is accessible, it's easy for us to quickly process and get on to building the model. And at the end, being able to present the clients with a useful solution to that problem. And that takes us to the next point where I will pass on back to Gavin.
Thank you, Maya. All right, so to wrap up, now that we have kind of given you a little bit of an overview of DWave as a whole, some more details at a lower level of how our hybrid solvers work and which use cases we've seen have had the best fit and best results. I will walk you through the engagement model that you will use when we contract with our professional services team to have assistance with creating those solutions and getting the business value out of the solutions being run into production. First, I will start a little bit with the roles of the professional services team. So the DWave professional services team is a global team. We have these roles throughout the world. And each one of these roles, at least one, will be part of each customer engagement that we have. The first is the engagement manager. So this is a project manager who will help manage the project, help manage the tasks, communicate and coordinate with our internal team, as well as the customer, to make sure that the customer is getting everything that they need of or that they have requested as part of the project. The second role is the solution architect. So as you've heard throughout the explanation from Pierre and Maya, our solution architects will work with the customers to be able to understand the problem, understand the data, understand the constraints and the requirements of the project, to be able to take that and build that mathematical formulation. And then work hand in hand with the third role you see here, which is our developers. Work hand in hand with them to not only, the developers will not only set up the development environment, will not only implement all of the software necessary to process the data, but also work with the architect to be able to put that formulation into code, to access the quantum computer and the hybrid solvers, as well as once we have it up and running, to be able to validate it and make sure that the customers are getting back the output that they want in the format that they need it. I mentioned on the first slide that we have over 30 use cases that we have done in professional services projects. Here is a list of them. I won't read them all to you other than to show you that they do span multiple markets, they do span multiple industries. And while some of these use cases are very specific to those market and industries, you'll see a couple that span all of them. We have some resource scheduling on here from machinery and humans, as Maya had mentioned in her example. Obviously, that will span all of these markets and industries, as well as some of the project scheduling, some of the tasks and the projects and the resources that go along with the work that's being done in these industries. Again, those are universal and can span across all of them, while some of the other use cases we have are very specific to these markets and industries. Okay, now for a little bit more detail on the launch program. So I mentioned earlier the professional services customer engagement model is called our launch program. You can see from this slide that there are 5 different phases to that process. I'll walk through each one of them, but I'm going to start all the way on the right, because the goal of this program for customers as well as DWave is to get as many of those applications into production as possible, so that the customers can really see the true business value of running those solutions in production, and getting the return on their investment by getting the value out of the solution that we put in place. But in order to get there, I'll back all the way up to the left. We have our discovery phase. If a customer comes to us and does not necessarily have a fully defined use case, we work with them to make sure that we can help analyze their possible use cases, their possible problems they want to bring to us, see which one is a better fit, see which one would potentially have the less effort to get it completed, but also add the most value. And out of that process, out of the discovery process, we will develop a roadmap so that all of the use cases that the customer has, will eventually be able to put through this process. But we will identify, based on the criteria that I mentioned earlier, the fit, the effort, the value, and the readiness, which one we think is the best one to start with, and go through the 3 middle phases of our launch project. You'll see that what's encapsulated in the white box there. Those are the 3 main phases of our launch process. Once we pick that use case, or if a customer comes to us with one already defined, we start by going into our proof of technology phase. Here, we work with the customer to understand the problem a little bit better, a little bit more detail, making sure that we fully understand the problem as it exists today. We will put together an initial formulation with some initial results, but I want to qualify that this is just an initial formulation, an initial set of results, just really to prove that we can solve the problem. We will do that based off of a subset of the constraints. We will do that based off of one data set. And again, the main point of this phase is to show you that we can get a solution, we can get results, and we will begin to estimate the value that it will bring to you, and then therefore get your approval to move into the second phase, which will be the proof of concept phase. In the proof of concept phase, this is where we fully implement the solution. We fully implement all constraints, all goals. We do that across multiple data sets, where we'll begin to benchmark against those data sets to make sure that the solution is the best one for your complete set of data. We will do some iterative formulation work, and that, based off of that and based off of the results that we've gotten and the feedback that we get from you, we'll continually refine and iterate on the formulation. And again, making sure that, we are confirming and marching towards a result that will get you the best business value possible. Once the proof of concept phase is done, we move into a pilot phase. And here is when we take that output of the proof of concept, the code that we have delivered, the solution, the formulation that we have delivered, and give it to you, deliver it to you, so that you can begin to build that out in your production environment. And as part of that process, of course, we will do some testing with some end-to-end data flows. We will do more testing from a performance tuning testing and integration testing to make sure that this solution is still working well within your production environment, and and assist with that or make any changes we may need to along the way. But out of that will come a production application that you will then have running in production, and again, getting the full value and realizing the value of quantum. Some of these have been touched on earlier by Maya, but we just want to reiterate that for each professional service engagement that we do get involved with our customers, there are a couple of things that have made them more successful, when customers have come prepared with these things in advance. The first one on the left, from a DWave perspective, again, having us involved in selecting the use case, is very beneficial to making sure that it is a good fit, and we can bring the rest of our knowledge and our information on previous experiences to be able to make sure that that use case will get the best results possible. But from a customer perspective, having a clear, defined problem up front, having a clear, defined set of requirements. To Maiwa's point earlier, having prepared data that we can have access to, as well as a team of experts that we can have access to. Having a dedicated team of subject matter experts, executive sponsors, data scientists, and projects leads who can help define the problem, help define the business value and context for solving the problem, helping to define the success criteria so that we know in the end of the project how we will be evaluated and what would define success for you, so that we can focus on that and making sure that our solution addresses that, as well as being able to answer our questions and get us access to all the information that we need throughout the project, again, to make sure that when we do deliver a solution, that it has results that match what the customers had in mind, or what they really truly is important to them and what they want to focus on. And with that, I think that is the end of our presentation. So I will hand it back to Susan.
Great, thank you very much, everyone. First thing, a little commercial for our annual user conference. This is, I believe, number 13 that we've done. So these have been going on a long time and growing every year. The user conference is called Qubits, and for Qubits 26 is going to be at the beautiful Boca Raton Resort in Florida. And if you want to find out more, we will have both presentations from DWave about our roadmap, a lot of educational parts to the agenda, along with we're going to be running a programming class at this. There'll also be lots of talks from enterprises and research organizations on the work they've done on quantum. And you can go to qubits.com to find out more about it. We also stream day one, so if you're not able to join us in Florida, we'd love to have you online watching day one. With that, we've had lots of questions come in, so if all of our speakers would come back on camera. First question, can you clarify when DWave reports availability at greater than 99%, could we interpret that to mean that any specific guaranteed metrics may be a point of negotiation for SLAs for production systems? So, Gavin, I'm not quite sure if this is an area you could answer, but I thought I would ask that question.
Yeah, that would, again, not necessarily, this team that would have the details of that. That would probably be our R&D team, who manages and supports the infrastructure as well as the solvers. But I do know that, we do have SLAs in place for our production contracts and our production environments that do define what that uptime is.
Okay, and kind of going along with that, to what extent is customers' data kept private?
Pierre Maiwa, do you want to address the data?
Yeah, we have different requirements for different clients, depending on the sensitivity of the particular client. We have rules around keeping our client data as private as possible. Some clients are happy with certain infrastructure when it comes to how we interact with our data internally. Some clients have more rigid rules. So we adapt to the rules and requirements of our client. But data protection is something that is very important to us, and one where we take very seriously.
Okay, thank you. Someone has asked a question about whether our hybrid systems are between our quantum annealing QPUs with CPUs, GPUs only, or do they include DWave gate QPUs? And I will say that this time they're using our annealing quantum computing systems. Our gate model product is still in development, so not currently available. All right, let's see. Your systems support optimization with higher order restrictions between variables. Does it also support non-convex optimization domains? Does it also support higher order objective functions?
Short answer, yes.
Okay, well, we like short answers. Let's see. I understand that problems need to be formulated in QUBO form. Is that right? What's the range of variables where DWave's quantum annealing nowadays offers a solution as good, better than classical methods within, let's say, less than 5 minutes? not quite sure. I think this is probably one of the it depends answers, but Maya or Pierre?
Yeah, so I would say if you're working on the QPU, I mean, you're going to be solving quadratic unconstrained binary optimization problems. But also remember, I mean, our range of solvers also include the nonlinear program solver, which can support higher order problems. So depending on the problem you're working with, you can make a choice of a particular solution approach that makes sense for the problem, but we can support higher orders beyond the quadratic.
Okay, and note that we did not talk at all today about quantum research, quantum simulation, et cetera. So this one, again, was really focused more on enterprise and organizational type problems. We've had a number of people ask, what have you seen in terms of the classical optimization solutions that customers are using when they decide to investigate quantum?
I'm not sure I understand the question. What do you mean? What have we seen?
In terms of what classical optimization solvers are being used when people will often compare quantum optimization to?
We have a wide range. Some customers have classical commercial solvers that have been in existence for a long time. Some customers also have explored algorithms like evolutionary algorithms, genetic algorithms, and some customers use open source solvers that are available online. So we see a wide range between commercial solvers and open source solvers.
Okay. Here's a question about how quantum systems would integrate into existing data center architecture and what type of workloads would justify this integration. So it's always a big question in terms of moving into production, what's involved, how does it fit in with the existing data center infrastructure that a customer would have?
So one thing I would say to that is there's a couple of aspects to it. If you're moving into production, we will work closely with you to figure out what the needs are. So there's an entire process, in particular with the professional services and our system folks. So that's on the one hand. So that's on a case-by-case basis. But on the other hand, the more general answer here, referring back to the architecture slide that I covered in the start, you can see this really doesn't require major change to existing or to pre-existing customer architecture. So whatever the existing customer data architecture or software architecture is, that can still remain the same, because the only handshake that happens with us is the encoded problem. So we are extremely flexible and extremely adaptable to working with different customers independently of their existing architecture.
Okay, there's a question here. Someone's asking, and I think we'll just have to correct the assumption they put in here. Why can't independent developers simply buy and use compute time on DWave Leap instead of being required to purchase professional support?
And the answer is you can. We do have QCAS dev licenses that will allow you to have access to that and use our Ocean toolkit and access it through our Leap cloud services. So you definitely can. But if you don't have the skills in-house, or want some help, that's when the professional services team, can be contracted with to bring our skills and experience to ensure that you're getting the best solution possible.
Yeah, and I'd comment on that. And we certainly have examples from customers who started working with professional services through a project, really then kind of learned and understood and got educated on how to use it, and then went off and did their own second application, third application, et cetera. Yep. So it really is kind of based on time and need and budget, et cetera.
And there are examples of customers who have done the QCAS dev, the do-it-yourself kind of methodology, and been successful. So there is ability to be successful in any or all of those avenues.
Okay, we have time for just a couple more. Someone says, hi, thanks for the webinar. From a mathematical standpoint, what are the key factors to look for once we have a high-level understanding of how to model the business problem in order to know if the problem will really make the most out of the hardware and find that quantum fit when compared with other options?
So some of the things we talked about today, one is where we have a lot of variables interacting with each other. So we want to say in the case of a scheduling problem, we have a lot of tasks, we have dependencies between tasks. Once we have lots of interactions between problem variables, those are the kind of problems where we shine on. We also have that when the scale is also one such that exact methods start to fail. You're not able to simply use very simple heuristic or even exact methods to solve that problem. That's also another area where we significantly shine. In terms of the decision variables, another factor which we talked about today is we shine more on discrete spaces. So if the decisions are one where you're choosing between discrete values rather than continuous values, we also perform a lot better on those.
Okay, here's a question. I don't understand the best use case problems yet. Is it simply problems that require brute force, discrete, multivariate space exploration, because those problems take too long to calculate, e.g. problems that neural nets pretend to solve but don't because they lack robust generalizations?
More often than not, if it's a problem that you can solve by exhaustively creating every possible combination of variables in a realistic time, it's probably not the best fit. But if it's one where we can't exhaustively search the search space, it just takes too long, then that's also one factor we look at when it comes to selecting a use case.
Okay, let's see. One more. There are a lot of questions, by the way. For the many that we're not be able to get to, I'll try and have somebody send answers over email here. Let's see. Someone is asking what the possibilities are in the area of fraud detection and possibly prediction. So does anyone have some experience with that?
Interestingly, this also gives an example of cases where people have done things outside professional services even and achieved success. So recently, one of our customers that are doing their modeling themselves reported good success with fraud detection using our contour annealing. So yeah, that's another use case where we've seen success.
All right. Well, with that, I think we're done today. I hope you found some value in our discussions today. Again, I'd encourage you to go take a look at qubits.com and either come to beautiful Florida in January or register for the virtual day one. Again, we will try and get some of these other questions answered over email. We thank you all so much for coming today and for your time. And thank you very much to our speakers. As a reminder, we'll send out an email to everyone who registered with a link to the recording and a link to get the slides as well. So thanks so much, everyone, and I hope you all have a great day.